So it's one of the slides that has a blue you see it on the right here.
So that's it?
That's it. And the scale of the resolution, the innermost pixel is hundreds of kilometers. Okay? It's about 100 kilometers per pixel or something. The object itself should be of 10 times smaller, so you can't really resolve it. What you're seeing here is the glow of light around the object from scattering sunlight. And the question is, what is producing that light? What is scattering sunlight? And the unusual thing about it, as soon as this was released, the comet experts said, oh yeah, now it's proven it's a comet. No, but I said, look, it's the sun-facing emission that is elongated. It's not the other side. The extent of the glow backwards, away from the sun, is the same as sideways. You don't see any cometary tail here.
Right.
And in fact, we're looking at it just like a cigar along the long axis. So it should be 10 times longer than it is wide if you were to look at it from the side. Amazingly, the best image was obtained on October 2nd, 2025, when 3i Atlas came within 30 million kilometers of Mars. And it was taken by the HiRISE camera on board the Mars Reconnaissance Orbiter, which is operated by NASA. As you remember, October 1st was the government shutdown. So October 2nd, the data was taken, but it was never released. I wrote to the principal investigator of HiRISE, asked, can I get the data? I'm a scientist. You can do the press release afterwards. I would like to see it.
Right.
No response. And so it's already 3 weeks since that data was taken. That is the best image yet to come. And the advantage of it, not only it has 30 kilometers per pixel resolution, because it came very close to Mars, which is one of the anomalies. Why does it come so close? This object is a gift from interstellar space because it comes in the plane of the planets around the sun, and it also, the arrival time was fine-tuned for it to come to the right place at the right time, to be close to Mars, to be close to Venus, and then close to Jupiter. And not to Earth. It's behind the sun when the Earth, when it comes closest to the sun. Anyway, so it's best for observations by all the space assets, by all the orbiters we have around Mars, around Jupiter, on the way to Jupiter.
So has someone seen this image from...
Yeah, the people on the HiRISE team must have seen it.
And what do they say?
And just, I get a request for 4 to 8 interviews every day from television, from podcasts and so forth. So just before I came to you, a few minutes before that, I was asked, could it be that this is a signature that NASA holds some really sensational data? And I said, it's much more likely not to be related to extraterrestrial intelligence, but to terrestrial stupidity. Because this has to do with the government shutdown.
Right.
Makes no sense whatsoever for scientists, especially since the PI, the principal investigator, is from the University of Arizona. They should have shared it with scientists. They haven't done so.
And why? But why?
Because my guess is they're taking their time. The communication office of NASA, is not working because of the shutdown. But given that this subject is viral, this is the HiRISE webpage. Thank you, Jamie.
So it says any images of Interstellar Comet 3.1 Atlas,
3i Atlas,
are considered NASA-wide news because the federal government is in shutdown. Communications of NASA news has been suspended. And so that's what it is? Like they would have to release it through NASA?
Maybe they have written in the contract that they need approval from NASA, but for NASA not to approve it...
But NASA can't approve it because they're not working.
No, Sean Duffy, the interim administrator, can definitely say...
Can you get in there? Why don't you call Sean? Say, hey, what are you doing?
I should try that.
Yeah, why don't you do that?
Okay, because, this is important because this would be the best...
This is the best image.
Yeah, 30 kilometers per pixel. But moreover, more importantly, it's watching, the camera was looking at the glow around 3i Atlas sideways because it was moving towards the sun.
Got it.
And it looked at it sideways. So we can actually see what exactly it was doing on October 2nd. And the claim is during September, the month of September, what looked like an anti-tail, a jet towards the sun, changed into a tail during September. So we should see October 2nd. What does it look like? And by the way, it's not like it was not a beautiful tail the way you see around comets. Never, ever. And
And that's because of the composition of it?
I don't know.
Right, because if it was covered with water, if it was just ice, you would see this enormous tail, correct?
And dust.
Yeah. Right.
So what the Webb telescope told us, from the data, it took a spectrum of the gas around it, found that it's 150 kilograms per second that this object is losing in the side facing the sun.
Mm-hmm.
And out of that, 87% is carbon dioxide, CO2. And 9% is CO, carbon monoxide, which is really dangerous to humans. And then 4% is water. 4% by mass is water. Very small fraction. When the object was discovered, the experts said, oh, it's most likely made of water. That's what they said, made of water. And then several teams reported, we found water. I looked at their papers. One of them had very large error bars. The data was not of good quality. There was a lot of noise, and I said that's not a clear detection. Another one was making some assumption about how much dust there is that blocks ultraviolet light, and based on that, they got a result that there is a lot of water. And then the Webb telescope actually measured the composition and found just 4% by mass water. So I was attacked when I said it's probably not real that these teams are reporting things, but they are not real, even though they made press releases. But then Webb demonstrated that it's only 4% by mass. Okay, so that proved my point, even though I was not a member of those teams. But so it's 4% by mass water, and then the question is there any dust? If there was dust particles that are half a micrometer in size, roughly the size of the wavelength of visible light. These kinds of particles scatter sunlight very effectively. If that was the case, you would see them being pushed, those particles being pushed by radiation pressure from the sun to trail the object from behind it, away from the sun. Why? Because they're being slowed down. The object is approaching at some speed. They are slowed down, so that then you end up with a tail going away from the sun. And that's what you see in comets. There was no evidence for that during July and August. Now in September, it seemed to have reversed from being an anti-tail to a tail. I want to see the image
but still a tail that's very small compared to other comets that we've observed, right?
Yes.
Now, how many comets have we actually observed? Is it just that there's so many out there that a lot of them have very unusual characteristics, like 3I Atlas?
Well, just think about an animal that visits your backyard, okay? And of course, your family members would say it's most likely a street cat because these are very common. Then you take an image of that animal and you see that, there is a tail, but it's coming from its forehead. And then you realize from the image that it's at least 1,000 times more massive than a street cat. And then you realize that it sheds nickel. And then you realize that it visits...
Listen, I understand that it's unusual, but my question is, how many of them have been observed to form this hypothesis that it's unusual?
We're talking about hundreds of objects.
Hundreds?
At least hundreds.
But how many of them have come from Interstellar? How many of them?
No, this is the second one.
Right.
There was Borisov.
Right.
Borisov was the one discovered in 2019, looked like a comet,
right.
Very similar to
That's the point. The point is that there's so few that have come from that are interstellar objects.
So that's why I'm saying it could be natural.
We don't have a lot to measure.
Right. So it could be natural.
Right.
And in fact, that may be the most likely association. But we need to figure out why it's so unusual. Okay, because
what is the shape of it?